Hello lovely people, what's up? Today we are solving Leetcode problem number 875. It's quite a popular problem, Koko eating bananas. So we are given an array that contains piles of bananas. There are n piles of bananas and the ith pile has piles of I bananas. And we have to finish all the bananas in 8 hours. So Koko can decide her bananas per hour eating speed of K. And at each hour, when she chooses some pile of bananas and eats K bananas from the pile. If the said pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. We are asked to return the minimum integer K such that she can eat all the bananas within the given 8 hours. Now let us take a look at the intuition behind this problem. What is Koko actually choosing? Koko is not choosing which bananas to eat. She is choosing her eating speed, that is K bananas per hour. Once K is fixed, everything else becomes automatic. So let us think it like this. If Koko eats K bananas per hour, can she finish all piles within the given H hours? This question has only two answers, that is yes or no, the binary answer. So here let's take an example like 3, 6, 7 and 11 and given H is 8. So let us take if K is 1. She eats 1 banana per hour, which will be extremely slow. It will take just 3 hours to finish the first pile and 6 hours to finish the second pile and 7 hours and so on. And let us take if she takes K is equal to 11. She finishes all the pile within 1 hour and it totally just takes 4 hours. And since the question is asking for minimum valid number, we are not simply picking a number that is greater than all of the elements' values. And the key observation here is as speed increases, K increases and the hour needed decreases. Meaning slow speeds in the given example will result in no. And a higher K value means fast speeds will result in yes and yes. As you can see, this shape is perfect for a binary search. We are searching not for a number inside an array, we are searching for the smallest K value that gives us a yes. And this is called binary search on answer. And we all know what a binary search is. It is like searching in a dictionary. We take the middle and then we see if our required word is towards the right or left, and then partition it again and keep doing this until we reach our required target. It is also to be noted that in the question, the length of the array will always be smaller than or equal to the given number of hours, so that we won't have any problems with the only one pile at a time condition. If you had noticed, the largest K value that we can take will be equal to the max pile given in our array. For example, in this array, the maximum value of K will be 11. Because we will know for sure if K is equal to 11, the entire array of bananas can be finished within 4 hours. Now what we have to try and do is to reduce the K value so that we can finish the entire array of bananas less than or equal to 8 hours. So we have to check all the values from 1 to 11 and find the minimum K value. To solve this question, we can initialize the range of starting from 1 to the maximum value. That is essentially, we assign a left pointer to 1 and the right pointer at the maximum possible K value. That is 11 in this case. And then using binary search, we can compute the middle by taking the average of left and right pointer and assign it as K and check if the entire array can be completed within the given h hours. And then to find within how many hours we can complete the entire array of bananas, what we do is we take the current k value and divide it with each element. So for example, if we take 6 and divide it by 3 and round it off, we get approximately 1. And then again, if we take 6 and divide it by 6, we get exactly 1. But then when we divide 6 by 7, it approximately rounds up to 2. Same goes with 11. So the total number of hours that will be taken is 6. But since we are looking for the minimum k value, we can try and further reduce the k value because 6 is clearly lesser than 8. So now we clearly know that the left side of our given range will contain the minimum value of k. Now we take the right pointer and shift it to k minus 1. In this example, 5. Because now we are searching the range of 1 to 5, 5 included. If the h exceeded 8, it would be the opposite. We will be searching the range of 7 to 11. We would have updated the left pointer. And then once we move the right pointer, we again take the average. We land on 3 in this particular example, and then we continue the previous process that we did over and over again until we find a perfect value of k. Now that we have understood the intuition properly, let us now look at the code. So first, we define a binary search range. The minimum possible speed is equal to 1 and the maximum possible speed is equal to biggest value in the pile. So the answer must lie in between this range. And then the variable result stores the best answer found so far. We initialize it with the worst case scenario, the largest possible value, that is the right pointer value. And while left pointer is smaller than or equal to right pointer, binary search loop continues while the range is valid. We define k is equal to L plus R floor divided by 2 to pick the middle speed to test. And then we initialize the hours to 0 to calculate how many hours Koko needs if speed is k. And for p in piles, the hours will keep increasing at the rate of p plus k minus 1 floor divided by k. And this p divided by k gives us the hours needed for that particular pile. And then we are adding all the piles together to get the total hours needed. And if the calculated hours is smaller than or equal to h, Koko can finish all the bananas within the allowed hours. And then we introduce the if and else clause. If Koko can finish within the allowed hours, speed k is valid, and then we update the result to k value. Then we try and update the R pointer to find the minimum k value possible and move the search left. If not, it is too slow and we move the left pointer to the k plus 1th element. Then finally, we return the result. As you can see, this code is properly running and resolving all the test cases. So that's all for today. Hope you guys enjoyed this problem. See you in the next one. Bye bye.